Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had discussed about different types of SI units and how to change these SI units into their multiples and submultiples. So, now we will discuss about the units and the unit conversions of different entities that is used to describe matter. For example, mass, volume, length, temperature, etc. And we have seen that there are 7 basic units which is considered as the base units by the SI system, and all other entities can be derived from these basic SI units. So we will learn about that also. So let's start. So first, let's talk about mass and weight. Okay. So mass of a substance is the amount of matter present in it. Okay. So mass of a substance is the amount of matter present in it. Okay. And what is weight? Weight is the force exerted by gravity on that object. Okay. So mass is written by small m. And if we talk about weight, let's say W is the weight, then it is written as mass multiplied by acceleration due to gravity. Okay. The standard value of G is equal to 9.8 meter per second square. So this is the expression for weight. Now we will derive the unit of weight from the unit of mass. Okay. So we know that SI unit of mass is kg. But we know that kg is a very big quantity. Okay, if we talk about a bag of 1 kg, it's a heavy substance. So when we are studying chemistry, we often have to deal with some matter which is very less than the weight of 1 kg. For example, if we are weighing chemicals, we generally do it in terms of grams or even milligrams. So since kg is a very big unit, in chemistry we generally use gram as the unit of mass. Okay. So, but the SI unit of mass is kg. Okay. So, we know, we have already studied that 1 gram is equal to 10 to the power minus 3 kg, or 1 kg is equal to 1000 grams. Now, if we are talking about the unit of weight, okay, so we have mass and we have G. G is acceleration due to gravity. So, what is acceleration? Acceleration is equal to velocity by time. Now, velocity is a vector quantity, but equivalent to velocity we have speed. So, velocity and speed have the same units. Now, we know that speed is equal to distance divided by time, right? So, speed is equal to distance divided by time. Then, acceleration will be equal to distance divided by t into t, that is distance by time square. Now, the unit of distance is similar to the unit of length. SI unit of length is meter, right? And SI unit of time is second. So, the unit of acceleration will be meter by second square, or we can write meter second to the power minus 2. So, since g is acceleration due to gravity, so g will have the same unit as that of acceleration. So, we have the unit of mass as kg and unit of g as meter second to the power minus 2. So, the unit of weight is kg meter into second to the power minus 2. So, this is the unit of force. Unit of force which is called Newton, okay? Newton. Again, we need to remember that when we are writing the unit in its full form, we will have to write it with small n, okay? And when we are talking about Isaac Newton, we have to write with capital N, this, okay? But this is the symbol for Newton. So, this is the unit of force. Now, by definition also, we had said that weight is the force exerted by gravity on the object. So, weight has a unit of force. Now, from here we can also derive the unit of energy. Okay, energy is equal to force into displacement. Okay, the unit of force is Newton. The displacement is nothing but length. So, the unit of displacement is meter. So, the unit of energy is Newton meter, which is also called joule. Okay. Now, if we break up Newton again, so Newton is equal to kg meter second to the power minus 2 into meter. So, we get 1 joule is equal to kg meter square second to the power minus 2. This is the unit of energy. So, we have seen that from the unit of mass, we have derived the unit of force and unit of energy. Okay. Now, the second entity that we will study is volume. Okay. Volume. Now, let's say we know already about the formulas to find out volume of different shapes. If we talk about a cube, what is the volume of a cube? Volume of a cube is the length of each side raised to the power of 3. So, this is the volume of cube. For cuboid, the volume is length into breadth into height, right? Volume of sphere. Volume of sphere is 4 by 3 pi r cube, where r is the radius. So, in all these three formulas, we observe that the unit of volume is somehow the cube of the unit of length. Okay, side is also length. For cuboid, all these three entities are length, and for sphere, radius is also length. So the basic formula is volume equal to length raised to the power of 3. Now we know that the unit of length is meter. So the unit of volume will be meter cube. Now this is the SI unit. Okay. Now since in terms of chemistry we generally measure length not in terms of meter but in terms of much smaller quantities like centimeter, millimeter, or even for microscopic objects we measure them in terms of micro, nano and picometers. Okay. Now when we talk about volume, generally in chemistry we measure volume in terms of ml or liter. Liter and ml is not the SI system. So we need to convert liter or ml into the units of meter cube or centimeter cube. Okay. By definition, 1000 centimeter cube is equal to 1 liter or 1000 ml is equal to 1 liter. So 1 centimeter cube or 1 cc is equal to 1 ml. Okay. So in chemistry, generally ml or liter is used as the unit of volume. Okay. Now we will learn the relation of ml or liter with meter cube or centimeter cube. Okay. So 1 centimeter cube is equal to 1 ml. Okay. And we know that 1 liter is equal to 1000 ml. So if 1 liter is equal to 1000 ml, then we can write 1 liter is equal to 1000 centimeter cube, right? So 1 liter is equal to 1000 centimeter cube, and also see 1 decimeter is equal to 10 centimeter, that we have discussed in the previous lecture. So 1 decimeter cube will be equal to, if the cube of 1 is 1, right? This. So 1 decimeter cube will be 1000 centimeter cube, right? So 1 liter is equal to 1 dm cube. Okay. So these are the relations between the meter and centimeter system with the liter and ml system. So these were the units of volume. The next entity that we will learn is density. So what is density? If density is D, then density equals to mass divided by volume. Okay. So the SI unit of mass is kg and the SI unit of volume is meter cube. So the unit of density can be simply written as kg meter to the power minus 3. Okay. This is the unit of density, but generally we do not use this unit in chemistry. In chemistry we use the unit of density is generally used as gram per liter or gram per ml. Okay. So we have discussed about mass, weight, volume and density. Now we will discuss about the units of temperature. There are three units of temperature: Fahrenheit, Celsius and Kelvin. Okay. So these three units are interchangeable. Now one interesting fact is that we know that when we are talking about Fahrenheit or Celsius, we talk in terms of degree. Okay. For example, the temperature is 40 degrees Celsius. Or when someone has a fever, we say it's 100 degree Fahrenheit. So degree Fahrenheit and degree Celsius is used. But for Kelvin, there is no degree. Kelvin is used in absolute terms, like 273 Kelvin. Okay. Now we will study about the interconversion of these units of temperature. So next we will study about temperature. Okay. So temperature has three units: degree C, that is Celsius; degree F, that is Fahrenheit; and K, that is Kelvin. Okay. SI unit of temperature is Kelvin. Now we will read about the relations between each other. Okay. Relation between degree Fahrenheit and degree Celsius is degree Fahrenheit equal to 9/5 into degree Celsius plus 32. This is the relation between degree Fahrenheit and degree Celsius. Now we can write in the reverse way also. If we cross multiply, then 5/9 into degree Fahrenheit is equal to degree Celsius plus 32. So 5/9 into degree Fahrenheit minus 32 is equal to degree Celsius. Okay. So these are the relations between degree Celsius and degree Fahrenheit. With Kelvin, it's a very simple relation. Kelvin is equal to degree Celsius plus 273. Okay. Or we can say degree Celsius is equal to Kelvin minus 273. Okay. Now let's see some examples. So we know freezing point of water is 0 degree Celsius and boiling point of water is 100 degree Celsius. So this is the range of temperature in a Celsius thermometer. Okay. So if we have a Celsius thermometer, we will have the temperature ranging from 0 degree Celsius to 100 degree Celsius. Now there can be thermometers in Fahrenheit scale as well as in Kelvin scale. For that, we need to convert these degrees to these different scales to get the range of thermometers in these units. Okay. So for Kelvin, it is very easy. For Kelvin, the range will be 273 Kelvin to 373 Kelvin. Okay. Now In the next lecture, we will discuss further about the unit conversion of temperature, and we will also discuss about some significant temperatures in these units. Thank you.